Welcome to all. We are considering I section now. Last class also I section, but today very important I section. I will tell something. Last class we considered random I section. See, if you remember, see, random I section. Something like this. This type of I section is not considered anywhere. Structural engineering, no. Even in examinations also, academic and any examination, usually they may give this question only for centroid or moment of inertia. But when it comes to application, see, you have to consider later bending stresses, shear stresses, buckling of columns. So this cross section will come many times. At that time, this is not considered. The most popular is, see, I sections here, two I sections here. See, this is I section with two axes of symmetry, or you can call this as, if you want, symmetrical I section. You write name here, symmetrical I section. I section with two axes of symmetry, that is x, y, y. See here, if this is breadth of flange, this is also breadth of flange. If this is thickness of flange, TF, this is also same TF. And one more thing, you write, there is no place to write here. The projection of the flange on either side beyond web is equal, or you make a small note somewhere. See, this distance, this and this, both are equal. You can make a note. See, light line right here, both are same. Same. I am removing it now. Okay. Let it be there, no problem. Same. This is symmetrical I section. Here, see, directly mark centroid G with the x, y, y. See here. X, symmetrical, and y, y. See, where is x? If the total height is h, because that is a symbol used in steel structures. If that is h, this will be h by 2. This is little out of scale. This is also equal to h by 2. If this is breadth of flange, this one, y, okay, y, this and this both are bf by 2 and bf by 2. Right here, x, y, both are axis of symmetry. Here, no calculation, no location of x, y by calculation, or x bar, y bar, no calculation required, directly mark. Okay, this is one symmetrical I section. Now come to next. I section with one axis of symmetry. This is equally popular. In so many examinations, what they do is, even practically also important, especially pre-stressed concrete. In pre-stressed concrete, the two flanges are not made equal. One side, little bigger will be given. Why? We will know the reason in pre-stressed concrete. So, practically also required. Examination point also very important, because usually such questions they give when they give short question. When they give little lengthy question, that's for 10-12 marks like that. Very popular section, this I section. Here, see, I will call this as breadth of flange 1, breadth of flange 2. This is breadth of flange 1, this is breadth of flange 2. That is different flanges. Thickness of flange is not required, different, not same thickness, you can see here. But one important, see, here also, this and this, both are same. Both are same. Same. Here also, see, this projection, right here, space not there. Here also, see, this projection and this projection, both are same. Both are same. Now, there is no place here, so I will remove this one. Okay, let it be there, no problem. Okay, now, here, there is one axis of symmetry. See, here, y. This y is axis of symmetry. With one axis of symmetry, that is y. Here, directly mark y. That is no need of, see, if you want to locate y, you require x bar calculation. No need of x bar calculation. Yeah, but to locate x-x axis, where is it? We don't know where. It is not a midpoint. Look at x-x. Find y bar. So this is y bar from bottom edge. See, y bar from bottom, y bar from top. Randomly written. Among these two, find any one of these. One of these two. Find any one of these two. Because once you know the total depth is h here, see, total depth is known. Once you know the total depth here, once you get this distance, you can find that one. Don't find both. So we require y bar. Therefore, remember, lastly I will tell, for symmetrical I section, see, last summary here, directly mark xx and yy, and if required, centroid G. Here, this I section, yy directly mark, yy directly mark, because this yy is axis of symmetry, but xx axis, for xx axis, for locating xx, or centroid G, y bar calculation is required. Make a note. These are the two important, you see question papers or any examination, these are very, very frequently asked. And other sections popular, exam point of view, are rectangular sections, circular sections, triangle rarely asked. All other shapes you are considering here, see something removed or some triangle, of course later some, see this also is there, that is important for pre-stress concrete. Otherwise, see some triangle coming, one rectangle, one more triangle there, that all is only for moment of inertia chapter. Otherwise, further application, they are not required. Okay, now I will take up this case now. What I will do is, first I will go for this one. Why? I always go in the reverse order. Reverse means what? Toughest first. Because as this is tough, as the tougher one becomes clear, easier one becomes further clear. If I take easier first, what happens is, when you go to little difficult one, suddenly people find difficulty. So, entire my teaching, I always do that way. I go, see, usually so many places, what they do? Simple first, then little more complication. No. Any chapter, anywhere, I first go for more complication. Make completely clear. Okay, once that is clear, what happens is, those examples where complications are lesser becomes more and more clear. That is the way I always teach. Okay, now I will first go for I section with one axis of symmetry. I will call this as, see, this is symmetrical I section. I will call this as unsymmetrical I section. I again told, unsymmetrical I section. I may not call anything I section. Actually, in English grammar, it is not unsymmetrical. It is called asymmetric. But I somehow feel unsymmetrical is more clear. As long as it is clear, do not bother about grammar. If anybody is going to class in a country where they use asymmetry, he will understand. General, used, unused, used, less used, used less, or avoidable, unavoidable, known, unknown. That way, symmetry, unsymmetry, I find more easier to understand. Okay, now I'll start. Start now. Question number 16. This is for unsymmetrical I section. Find moment of inertia about center of the axis. All in millimeter. Axis means plural. Right. First class. Right here. You should write. I am not writing everything here. Required. What is required here? Right here. What is required? See, to make the concept completely clear, what all I dictate, right? Required. Moment of inertia about centroidal axis. Plural means understood. Horizontal axis pass into centroid, say xx. Vertical axis pass into centroid, say yy, that is right here I about xx and yy. This all you write. Now there is one, now next write, after that one statement. See, one statement you have to write. The given I section, see, whatever is there, rough sketch, not exact scale, okay. This is a given I section. See, here, the two offsets are not given. When it is not given, understood, they are equal. So, here, this given I section is symmetrical about this axis. This is an axis of symmetry. Axis of symmetry, that is YY axis. Therefore, no need of locating YY. You require to locate only XX axis, means therefore you need only Y bar calculation. See, for locating XX axis. Write all that. Right. Then divide into parts. See, 250 by 18, 16 by 3, this is 300. 16 by 300. Now this width I not given, this is 150. I wrote it and rub it out, 150. This is 150 by 20, 20. Part 1, part 2, part 3. Okay, start. Mark centroid for each of them. See, exactly here, centroid. This centroid is very important, centroid. Here, the centroid for the middle, see, I will tell one more thing. One note I will give you later. See, this is G1, G3, this is, I put extra ink, that's why ink is flowing. Okay. This is G1, this is your G2. Make here, see, this all you remove now. Make a note there. That G2, see, that G2 is very, very important when you find I about XX. When you find I about XX, that G2 is very, very important. I will tell you it later why. Make a note. The G2 is very important to observe for IXX. G1, G3, no problem. Okay, start. To locate centroid G, Y bar from bottom edge, or say AB, equal to same formula, A1, Y1, A2, Y2, A3, Y3. I don't know how many times I have to tell. Write the formula. Here space not there, so continue. Equal to, start. A1, 150 into 20 by 2, this all I should not explain now, 20 by 2, plus 16 into 300 into centroid from here, 20 plus 300 by 2, plus 250 into 18 is next last one, into from bottom edge to centroid is 330. Remember, 338 is not given, we calculated how? 300 plus 18 plus 20, we got 338. So that area into 338 minus 18 by 2, or you can write 20 plus 300 plus 18 by 2. You write there. For this one, write there. Or you can write 20 plus 300 plus 18 by 2 divided by A1 plus A2 plus A3. Y bar, I got 189.146 millimeter. Now, one note you have to write. Don't see other. See, this moment of inertia, don't see. You see only that much. As you see, when I write something extra in the class, unless I explain that one, you should not see it. Now, class, go back and mark XX axis. YY directly known, XX, very important. But when you mark XX, see, be very careful about G2. Be very careful about G2. See, G2 is from bottom edge 20, you write here, from the bottom edge to G2 is 20 plus half of 300. 20 plus half of 300 is 150 plus 20, 170. From here to there is 170. Y bar we got 189.146. Therefore, make a note, very, very important. I am not writing on the board. Those who are serious right here, your XX will be slightly above G2. See, it is above G2. Very, very important. This question, your XX is above G2. Next question, it will be below G2. Both are equally important. Sometimes people get confusion. See here, 20 plus half of 300 is 170. Y bar you got 189. So this is 189. Now all this you remove, not required. None of them required now. Right here. From here, see this Y bar is 189.146 means then immediately mark from the top. From the top is 338. See, little out of scale, helpless. 338 minus 189.146. I already marked somewhere there. I made a note of the answer. That is 148.854. Yes, because these all I already calculated. Forgot. See, 148.854. 148.854. Okay. Now make a note. Suppose somebody will do Y bar from top edge. Then he will get 148.854. Then G2 is 18 plus half of 300 is 150 plus 18 is 168. Oh, since you got 148 there, it is slightly before G2. Both the ways, this axis, x over. Now, make a note. Directly, without calculation, see, exactly center, passing to G3, come down, and passing through what? G2, continue further without disturbing. Passing through G1, mark YY, over. You need not write any distances. If you are that much eager, actually not required, see, this is YY. You write here 150 by 2, 150 by 2, 250 by 2, 250 by 2. Actually, nobody expects to solve those things. Write that one. Okay, now, calculation of moment of inertia about centroidal axis, that is IXX and IYY. Now, I want more space. Okay, I will remove this one now. I want more space. Again, remember, G2 for IXX, very important. This is giving little trouble to me. I will mark YY here. 150, I slightly shift upper side. 150. Okay, now, see, now I told you, when you do moment of inertia, that G2, for when you do I about XX, G2 is very important. Okay, this is over. Okay, over. Start. This also, that will be there next question. That will be there for next question. Okay. Now, start. By parallax theorem, I about any axis equal to this ink problem. I have put too much of ink. So therefore, it is spread Ig plus AH square. If anybody will ask me, sir, not clear means, discontinue my class. Okay, over. Now start. I about XX. I will explain very systematically for this question. Start first. This is G2. See, the G2 is very critical. I told you, G2, be careful. Be careful about G2. Especially careful for IXX. For I about XX. IXX, when you calculate, G2, be careful. Okay, start. Start here. First, come to centroid. Figure number 1. Come to centroid. Axis passing to centroid and parallel to AB is this axis. 150 into 20 cube by 12 plus area 150 into 20 into from centroid to the XX axis. See, from centroid to XX, see, this distance square, that is 189.146 minus half of 20. It's very easy to understand. Okay, then now comes second one, plus. See, the most important part comes now. Plus, this will go inclined. Okay, this way. Okay, go part. Second one, be very careful. Come to G2. Now you should be careful, alert. See, right here. Be alert. Come to centroid. Axis passing to centroid parallel to XX. This is the axis. 16 into 300 cube by 12. This is no problem. This is not the problem. Plus area. 16 into 300 is the area into, this is the most important term where people get confusion, into from centroid to xx, see this distance square. Now be careful, your G2 is below, right here. When you write this one, you write all the statements here, what I am telling, statement. The G2 is below xx here. Next question, it will be above xx. I will explain both. G2 is below xx. So use the y bar from bottom side. 189.146. 189.146 is from xx to extreme bottom. Your G2 is here. So from what, see, we want this distance square. 189.146 subtract 20 and also subtract half of 300. Subtract 20, also subtract 300 by 2, that square. Be careful. See, very crystal clear, this distance square. See, since G2 is below, use this distance. 189.1, see, we want this distance. 189.146 minus this distance is 20 and 300 by 2. Or, make a note, or, this is if you look below, see, if you look bottom side, this side, or if you look upper side, see, look upper side, then make a note. If you look upper side, see, this G2 is below xx. So if I use upper side, this is 148.854. So from G2 to here, this distance square is required. So from G2, first to go to extreme distance. Don't use this one. See here, first to y bar, then subtraction. Here not that way. First to that number. From G2 to here is 300 by 2. Or it is 300 by 2. 300 by 2 plus 18. First write distance of G2 from topmost, see here, first write y bar value, then subtract. Here not that way. From y bar value, subtract the distance of centroid from bottom. Here reverse. From G2, first write distance to top extreme fiber. 300, how much it is? 300 by 2 plus 18 is from top up to here. From this distance, subtract 148.854 minus 148.854 square. Anything will do. Both will give same answer. Be very careful. This also over. Okay, now one more is there, plus. This is very easy, no problem. Start. I about its own centroidal axis. 250 into 18 cube by 12. 250 into 18 cube by 12 is Ig plus area 250 into 18. 250 into 18 is the area into from centroid of this component to xx axis. See, this distance square directly 148.854 subtract 18 by 2. 18 by 2, 18 whole square over. See, we want from centroid G3 to xx, this distance is 148.854 minus 18 by 2. So, when you consider G2 for Ixx, see, G2 is below this distance minus this distance, or this distance minus this distance, whole square over. This is Ixx. Answer I am not interested. You calculate and write whatever is the answer. Answer not required. Okay, start. Iyy. First of all, you have to make a note. When you find I about yy axis, see here, your G1, G2, G3, all of them lie in the yy axis because why? Symmetry. Therefore, when the time comes for Ig plus AH square, see, from here, when you do I about xx axis for G1, from x axis, this distance square, this distance square, this distance square. But when you do about y, it is this way distance. But this way, no distance because G1, G2, G3, all the three lie in the y. So only IG answer, area into 0 square, or observe here, start. First I about its own axis. See, you can make out that own axis and y both are coinciding. See here also, see, first I about its own axis, center parallel to y. It is coinciding, see, axis passing to centroid parallel to y is coinciding with y. So all the three centroidal axis parallel to y coincides with y in 0 square. So start for this one, IYY. 20 into 150 cube by 12 plus area into 0 square. See, 0 square. Why 0? From G1, see, perpendicular distance to y axis. G1 lies in y. Okay, then here 300 into 16 cube by 12 plus area into once again 0 square, 18 into 250 cube by 12 plus area into 0 square. You get IYY. Calculate the answer. Anyway, next I am uploading next class shortcut for moment of inertia for both symmetrical and unsymmetrical. Even for unsymmetrical, there is a shortcut. But I will tell you next class. One special, I show that later when I go to bending stress chapter or columns at that time, strength of materials, when moment of inertia comes, this much I will not explain. I will tell them, if you are serious, go back to at least engineering mechanics now, search for moment of inertia, see where I section is there, search it see my class is in correct order. Or I may note down the class number. I may tell you the class number at that time. Or I may not tell. I will tell, go and refer. Where you can see first randomly I section, don't that one. Next I did important one. Then next one more class I given, taken, where shortcut I told. So go through and understand. Okay, now question 16 over question 17. Question 17. Find moment of inertia about same thing. Question I will write and start. I will tell one more thing now only. One more thing now only. In the next question, what will happen is your XX will come below G2. Remember, it will come below G2. That's what I want. Second question. Start now. Next question. Question number 17. Oh, I forgot to remove this one. This I will remove. See, this all I will remove now. This I will maintain so that I can start fresh. Okay. See, correctly. Second question. 125 by 12.5, 180 by 10, thickness is 8, 300. See, last time this is given 300. So total was that 300 plus this one and this one. Now total is given 300. So this distance you have to get it now. How much? From last time to see this distance, given distance, you add these two. Now from the 300, you subtract this and get the distance. That much common sense required. Start first. First, what all I told last time, write once again. This is symmetrical about y. See, put one more sketch here. I won't waste time unnecessary for this one now. Whatever given, right here. This I section, right? It is symmetrical about y. So y directly located here without any calculation. Axis of symmetry, everything you write. So therefore, since it is symmetrical about y, no location of y. When there is no location of y means no x bar calculation. You require only what? Only y bar calculation. All those right here. Start. to locate centroid G, y bar from bottom edge, say AB. Okay, some reference name, say AB. AB. Start. A1 formula all same. I should not explain this one. See, A1, 180 into 10 into half of 10. Then 8 into 277.5 into 10 plus half of 277.5. 125 into 12.5 into 300 minus 12.5 by 2, or 10 plus 277.5 plus half of 12.5 divided by total area, you get y bar. Okay, now make a note. Now important. When you locate y bar, be careful about G2. G2, keep in mind. See, y bar you got from bottom edge 142.984. Before that, you write here. From bottom edge to G2 is, you should write in the, somewhere outside you write. From the bottom edge to Y2 is 10 plus another 277.5 by 2 is 148.75. It is 148.75. See, from the bottom edge to G2 is, how much I told? 148.75. But y bar you got 142. Therefore, your x-axis axis will come slightly below G2. See, last time it came slightly above G2. This time x-axis is, okay, this I'll remove now. X-axis is below G2. Okay, right, mark here. That is very important. If you mark wrong way, distance problem later. This is how much? 142.984. Then from top edge to here will be, from 300 subtract 157.016 is from top edge. Correctly mark. This is x-axis axis. Now, y axis directly mark without any calculation, passing to centroid of each component. Y. If you want, write here 125 by 2, 125 by 2, 180 by 2, 180 by 2. If you want, I don't want it. Okay, now start. Moment of inertia calculation. Right. Calculation of moment of inertia, Ixx, Iyy. Write parallax theorem. You write. Okay, then next is 18. I'll make a note. Next 18. Okay. I'll remove this one now. Now be very careful. Start. First Ixx. I want more space now. Ixx. So start. Ixx equal to I about x-axis axis. One is camera. Whenever I come to extreme edge, I get doubt about the camera. Oh, no problem. Okay. See, what all I explain, you should write. Start. First, figure number 1. Come to its own centroid. Axis passing to centroid G1 parallel to which one? X-axis, this axis. 180 into 10 cube by 12. This is very easy. Into 10 cube by 12, Ig. Plus area. 180 into 10 is the area into, from centroid G1 to x-axis axis. See, this distance square is 142 point. I want it more space actually. Okay, I'll manage it. 142.016 minus 10 by 2. Okay, I'll do one thing. I'll write here. Okay, their problem is there. Okay, start. 180 into 10 cube by 12 Ig plus area. 180 into 10 is the area into, how much I told? From centroid to x-axis, 142.984 minus 10 by 2 whole square. This already I told last time, same as last time. No problem. I'll put below. Plus the most important. See, now be careful. Be careful and understand. Be careful. G2. See, G2 is here. First come to its own centroidal axis. 8 into 277.5. 8 into 277.5 cube divided by 12. This is no problem. Plus area. 8 into 277.5 is the area into, this is the most important, from centroid G2 to XX, see, this distance square. Last time your G2 was below. This time it is above. Therefore, since the G2 is above, when you want this distance, see, this distance, you use upper side first. 150, use now. Now this is 157.016. See, from G2 to here we want. This distance square is 157.016 minus 12.5 minus 277.5 by 2. Oh, all should be red color. Okay, red color, okay, no problem. This one to be squared. If you look upper side, or make a note, or if you look lower side, nothing to worry, see, lower side. G2 is here. From G2, first come here. 277.5 by 2, 277.5 by 2 plus 10. From G2, come to extreme end here. From this distance, subtract 142.984. That distance to be squared. Okay. Now, next, close the bracket. Last one, plus. This is easily. I about its own centroidal axis. 125 into 12.5 cube by 12. 12.5 cube by 12. Cube, okay. I am reading it. Sometimes writing may not be clear. Plus area, 125 into 12.5 is the area into, from centroid to XX, see, this distance square, that is 157, this is easier, 157.016. From that one, subtract half minus 12.5 by 2 whole square. We will use for last one. Close, calculate and get the answer. Okay, now I about YY. Now I will not explain. There is a limit for everything. See, just now I explain. When you want I about YY, see what happens. G1, G2, G3, all of them lie in the YY axis. So from centroid G1 to YY, G2 to YY, G3 YY, perpendicular distance is not there, 0 square. Or when you mark its own centroidal axis, it coincides with YY. See, horizontal distance is not there. Already explained. If you are not properly written last time, if you are struggling, struggle. Okay, start. 10 into 180 cube by 12. Actually, that's all. But still, plus 10 into 180 is the area into 0 square. 0 square. First one is over. Plus second one. 277.5 into 8 cube by 12 Ig plus area 277.5 into 8 into once again 0 square plus last one 12.5 into 125 cube divided by 12 plus 12.5 into 125 into once again 0 square. Already explained just now. There is a limit for everything. Okay. Get the answer. Over. Next, I will go for question number 18. Question 18 and 19 both simultaneously. 1 minute. 18. I will write and start. No. 2 questions for symmetrical I section. You can make a note. First question. Find moment of inertia about centroidal axis. 216, not given. See, you make a note here. Not given means understood. This also 200 by 16, 12, 250. Okay. First, some statement you are right. This I section is symmetrical about both YY and XX. Therefore, no need of locating the axis by calculation. X bar not required, Y bar not required. Exactly horizontal XX is vertically midway. Vertical axis YY is horizontally midway. So, divide into parts. 200 by 16, 12 by 250. See, 250 is this depth. This is again 200 by 15. Total depth is 250 plus 16 is 282. Okay, then XX axis, exactly midway. If it is 282, right here, how you got 141? This is 282 divided by 2. This also 282 divided by 2. This is both 100, how you got 200 by 2. Okay, correct? 250, 50. Correct. Okay, now start. Now calculate moment of inertia. Write the same statement. IG plus. See, next class for symmetrical I section, shortcut is there. But today I am not giving shortcut. Next class, shortcut for both symmetrical and unsymmetrical. Both I will tell you. Very useful for examinations. Okay, start. Usual statement you write. Then, before you starting calculation, make a note here. I about XX for 1. See, for 1. For actually you calculate for 1. See, this is G1. 1 nimisha. This is your G1. Okay, rubbed out. This is G3. This is part 3. Make a note. See, IXX for 1 you calculate for 2. For 3 not required. See, how is the dispersion this way? Same that way. Same for YY also. So, since it is perfect symmetrical, I about XX for 3 equal to I about XX for 1. Same way. I about YY for 3 equal to IYY for 1. So calculate for 1, multiply by 2 outside. Then for 2. See, start first. For 1 first. First about its own centroidal axis. See, its own axis. 200 into 16 cube by 12 plus area into from centroid to XX distance square is 141 minus 16 by 2 whole square. This will give IXX for 1. Do not waste time, multiply by 2. Why reason? Because I about XX for 3 equal to I about XX for 1. You write there, into 2. Next, come here. 12 into 250 cube by 12. This time, see, last time, one question, G2 was above. One question, G2 was below. Now G2 is coinciding with the XX, therefore 0 square. See, from G2 to XX, no vertical distance, 0 square. Calculate the answer. Okay, then, same way, I about YY. Start. 16 into 200 cube by 12 plus area into 0 square y, G1 lies in YY. Multiply by 2 because, reason, why 2? Because I about YY for 3 equal to I about YY for 1. Okay. Whatever you got for this one into 2 plus for this one, I about its own axis. 250 into 12 cube by 12 plus area into 0 square over. This will complete. Easy question. Next class, I will explain everything and give shortcut. At that time, I may take the same example once again. What I take, so answer required now, you calculate and get the answer. Okay, now, this is over now. I will go to next question, last question. Last question actually is exercise. I will make a note here. The last question, question 19, you solve. I will give the answer now, you solve. But only thing is given by words. See, find moment of inertia about centroidal axis for an I section 300 by 400. See, when it is not given, it is understood that First given is a horizontal dimension and next given is vertical dimension. And one more thing, it is actually, see, when you tell 300 by 400, somebody will think rectangle. No, that 300 by 400 they are giving is what? Boundary dimension. See, that is boundary dimension, this way. This way. So that means they are telling you, okay, here, little this side, okay, symmetry is there. That is, this is 300. This full is 400. See, full 400 now. Full is 400. And then they told flanges are, see, flanges, plural, means both are same, 12 mm thick. This flange is 12, this flange also 12. If both are 12, the web thickness will, the depth of web will be, how much it is? You have to calculate. Last time this is given, you added, this time subtract. From 400, subtract 24. 376. This is 376 calculated value, and this thickness is, how much? Web thickness is 10 mm. This is 10. Visible? Okay, I will do one thing. If not visible there, I will put here 10. Okay, now for this question, you solve yourself only. I will give direct answer. See, first of all, divide into parts this way. G1, G2, G3, part 1, part 2, part 3. Shortcut next class. Now, directly mark. XX comes here. YY comes here. You write. If that is 400, this is 200, 200. Both are 200, 200. YY, both are 150, 150. IXX, I will read 300 into 12 cube by 12 plus 312 into 200 minus 12 by 2 whole square into 2 plus 10 into 376 cube divided by 12. IYY, 12 into 300 cube by 12 into 2 plus 376 into 10 cube by 12, for both of them area into 0 square. I will directly give the answer this time. See, you solve. So answer is, this time I am giving answer. Correctly solve and get the answer. You get IXX answer and IYY. IXX is 300 into, I will do my own calculation. Let cube minus 290 into 376 cube divided by 12. 363 10 to the power 6 millimeter power 4. I will check once again. 12 square plus 300 200 minus 6 plus square plus 10 into 376 cube. Correct. IYY is 12 into 300 cube divided by 6 plus 376 into 10 cube. I am slowly doing because my calculator is not in correct order. Otherwise, I can do in just 15 seconds because I do not want wrong answer. 54.031. Next number I am not writing. 10 to the power 6 millimeter power 4. This is, I check once again. 300 cube by 12 plus 376 into 10 cube divided by 12. Yes, correct. Over. Solve this question. Solve. See, now same next class what I will do is, next class question number 16 and 17, they are unsymmetrical sections, and question number 18 and 19 symmetrical. For all of them, I'll give you shortcut. Very useful from examination point of view. You can find moment of inertia very easily, but of course little work is there. This much struggling not required, especially in the examination if steps are not required. Suppose it's objective question or too much writing is not required, you can use shortcut. Next class I will tell it. I will write heading shortcut method for moment of inertia, shortcut method for moment of inertia for I sections, both symmetrical and unsymmetrical. Along with that, I may tell even for hollow rectangular section also. That also same principle. Okay. Thank you. We'll meet next time.